Good evening, and welcome to Skep Talk, the monthly speaker series hosted by the Bay Area Skeptics. Before tonight's presentation, a few words about Bay Area Skeptics. As North America's oldest skeptical organization, we are dedicated to promoting critical thinking, logic, and rational thought. In the 1970s and 80s, scientists such as Carl Sagan and magicians such as James Randi established the scientific skepticism movement out of concern about the popular fondness for pseudoscience and the lack of public science literacy. Scientific skepticism embraces evidence-based civil discourse on health, education, consumer protection, and especially the investigation of extraordinary claims. Using the scientific method, we hope to promote skeptical inquiry to reduce irrational thinking in society. This talk is supported by Bay Area Skeptics members such as you. Please visit us at baskeptics.org or join us on Facebook, Twitter, and Meetup. Consider supporting us through convenient monthly donations via Patreon. Patrons receive premiums such as discounts and free t-shirts for our annual Skeptical Conference. But more importantly, members help us make the world just a little more reasonable and rational. And now, tonight's speaker.
Good evening to all. Thank you so much for tuning in tonight for our Skep Talk for the Bay Area Skeptics. And we really have a treat for you tonight. I know we have Carl Zimmer, who's going to talk about his new book tonight. Answer some questions if you have some at the end. First, let me tell you about this gentleman. Carl Zimmer has been a science writer and popularizer for decades, an editor for Discover Magazine 10 years. He now writes the Origins column at the New York Times, where he's written about science for over 20 years. Zimmer is also the author of 15 books about science and numerous awards for his work, including the Stephen Jay Gould Prize from the Study of Evolution, the 2007 National Academy's Communication Award, American Association for the Advancement of Science's Science Journalism Award. 3. He's been a frequent lecturer at many universities and a guest commentator on radio, regular guest on National Public Radio's Science Friday, Fresh Air, and lots of others. His skeptical bona fides are solid too. He's been a presenter at Nexus and Con. He's adjunct professor at Yale, where he's taught for 15 years. He's likely you'll meet who has both an asteroid and a tapeworm named after him. His book, Air-Borne, The Hidden History of Life We Breathe, Zimmer digs deep. The nature of the aerobiome was discovered over the centuries, beginning with aerobiology, who stretched the limits of science and were doubted for generations. He conducted the recent pandemic as a part of a bigger and largely untold story and explores how is an essential part of a living world, highway through the sky for many species, of which we become part of with every breath we take. His book is an exciting excursion of the critical players, frequently taking side roads to delve into the backstories of the men who fought hard for change of paradigms and bring new ideas into the open. It calls to mind writings of Jacob Bronowski and James Burke, those wonderful philosophers who appreciated the quirky details that are so important to the narrative, but that often for the larger picture. So, without any further ado, it gives me to introduce a bona fide superhero defending science for all of us, Carl.
Thanks, Bill. It's great. It's really great to be here. I really appreciate it.
Well, we are so glad to have you, and I can't wait until you get into this. I want to point out a couple of books that I've got. I first came to your attention, I think is the way I should say it, when I was listening, I think it was Science Friday, but you were talking about your 2011 book, Science Inc., which categorizes all these wonderful pictures of tattoos that you had collected from people who had science-based tattoos like DNA structure and Mesozoic dinosaurs and things like that. It was wonderful. Now, of course, we're going to talk about this book, Air-Borne, which is your latest book. And you're going to get into this, but I first just want to ask one question. I mean, it's really cool, science and all that, but really, like one of the things you go into is a brief pasteurization of milk. I mean, does that really have any relevance today? I mean, raw milk nowadays?
Yeah. I didn't think that I didn't think that the germ theory of disease would be quite so relevant to talk about today, but it really is. And so, yeah, I think my book came out in February. I had finished it last year, so obviously I had no idea that Robert F. Kennedy, who literally promotes miasma theory, would be in charge of American health. But here we are. So so I think our critical skills at understanding how science works and how we know what we know are really more important than ever, even if they're facing really unprecedented challenges.
Oh my goodness! Yeah. Oh wow. Well, I can assure our audience that this is a wonderful read. It is very, very enjoyable. You're a wonderful writer, of course.
Thanks.
Sorry that it has to be so relevant. So I think in a way, Carl, could you elucidate? Could you educate us on?
I'm sorry, you cut out there. Could I educate you on what?
On just just tell us what we need to know, my friend.
Oh, okay, great. Yes, Bob, happy to do so. And again, thank you, Bill, for having me. Thank you, Bay Area Skeptics. It's a real pleasure. And I actually have some slides, so I think I'm going to hop over and get those started. And so we should be good here. Great. Well, again, thank you for having me. And yes, I'm going to be talking about some of the things that I write about in my latest book, Air-Borne. The book is about the life that surrounds us and that actually enters our bodies with every breath we take. Of course, if you look up in the sky, life may not be the thing that comes to mind. You might just think well, there's some clouds and some sunlight, maybe some nitrogen, some oxygen, and that's about it. It's mainly because aside from the occasional bird, you just don't see much that's alive there. I mean, if you look down at the ground, like I look in my front yard, there's lots of life. There are snapping turtles and there are flowers, there are alliums and so on. And so so you can see it. And so it feels more comfortable to be aware of that. But in fact, there are these different biomes on the planet, and the one in the air, the aerobiome, is an important one. It's a real one, but we didn't realize it for a long time. That's not to say, however, that it didn't affect us. One of the ways that it affected us was that early farmers had to deal with mysterious outbreaks that would suddenly strike their crops, and they didn't know how these things happened. So, for example, wheat rust, which is a fungus that travels through the air, it would suddenly wipe out whole fields. This was something that led, in the Bible, when God is threatening to smite his people, one of the things he says is he's going to bring wheat rust to them. And the Romans actually also were burdened by this too. This picture I'm showing is actually a calendar from ancient Rome. And the ROB is standing for Robigalia, which was a holiday where dogs were sacrificed and there were other rituals performed in the hopes that the gods would not punish farmers with wheat rust. Again, coming out of the air, but they didn't know it. The air was a mystery, but at the same time, people like Hippocrates looked at it and thought that they could see an explanation for why people get sick. And so they would refer to the cause of diseases, many diseases, as being miasmas. And so miasmas are like corruptions of the air. And Hippocrates actually once wrote, when the air is full of miasmas, whose properties are hostile to human nature, this is when men are ill. But when the air is not suitable for another type of living beings, these beings are then ill. So in other words, miasmas are floating around. They're generated by all sorts of physical factors or influence from the stars. And different miasmas cause different diseases, and they even affect different species. This idea of miasmas was incredibly powerful. It had real explanatory power, so much so that even in the 1800s, leading medical experts took it as a given. And so when cholera came to Europe in the early 1800s, spreading from major outbreaks in India, European doctors looked at it and said, well, this must be spreading through the air, through miasmas. And this really striking cartoon shows kind of how people envisioned the spread of cholera, like that this was basically like moving with the clouds, and it was drifting over these helpless soldiers. They may have their weapons, but the miasma, as it says here, tramples the victor and the vanquished both. Now, it turns out that miasmas are not real, despite what Robert F. Kennedy might say. And one of the glimmers that miasmas are not real actually came from the Irish potato blight. And this painting shows farmers who are discovering that the potatoes that they've raised and that they're trying to survive on have been ravaged by this blight, late potato blight. And these are some potatoes that have it, and basically it just turns them into this sort of dark mush that's completely inedible. This was devastating to Ireland. Over 1 million people died, millions more left Ireland. It was a disease that was spreading throughout much of Europe, but in Ireland, they were extremely vulnerable to it because of how the British were running the food system there. So in other words, food was being grown in Ireland, but then exported, and then the poor Irish workers had to grow potatoes on their own to survive. And it worked most years. Potatoes are a great source of nutrition, but when the blight hit, it was devastating. And so there's lots of questions, lots of basic scientific questions. Where is the blight coming from? What is it? And there were miasma-like explanations for it, that there was some sort of disturbance in the air that was spreading and causing this. However, there were naturalists like a British vicar named Miles Berkeley, who would look at these potatoes, and under a microscope, they could see that there were microorganisms in them. Some people would say, oh, these microorganisms, they just spontaneously generated in these decaying potatoes. And Berkeley and others said, no, these are the cause of the disease, and they are spreading from potato to potato. It's a germ theory of late potato blight. And one really important way that Berkeley believed that things like potato blight or fungi would go from farm to farm was through the air. In other words, spores would be able to travel long distances and cause new infections. Louis Pasteur was hugely important in overturning the old miasma theories and bringing the new germ theory of disease in. And what I write about in the book that I don't think a lot of people know, I certainly didn't really appreciate this before, was that he was very committed to demonstrating that there were microbes in the air, that there were floating germs around us. And he believed that this was a major source of fermentation, decomposition, that he believed that germs were floating around and landing on the ground and breaking things down, which is good because we need them to be broken down to cycle nutrients. We don't want things just piling up all over the place. And so Pasteur actually took an incredible journey to the top of a glacier in the Alps, holding up these flasks in order to capture these germs, which he did. And he would bring these to Paris and demonstrate indeed that there is life in the air all over the place, even at the top of a glacier. There were other people who sort of followed on these initial studies and these pioneers. Charles Blackley, for example, made the discovery of pollen in the air at incredibly high distances. He was motivated by hay fever, which he suffered from terribly. And he was inspired by Pasteur and by others to try to capture pollen in the air. And he wondered how high could he catch it. So he actually built himself a kite that could go up over 1,000 feet in the air. And he had sticky little traps on the kite, which could catch these pollen grains. And he actually was able to catch pollen grains at incredible altitudes. And he could even catch them when he was having his kites in the wind blowing from the ocean, which meant that these pollen grains must be traveling incredible distances, not just giving Charles Blackley hay fever, but also spreading the range of these plants, these incredible distances. So by the early 1900s, these ideas of miasmas are being pushed aside. Now, for people who study diseases of plants, who want to protect crops and avoid famines, it's pretty clear to them that there are fungi like black stem rust and these other pathogens that can travel long distances through the air. And this is a cartoon from the early 1900s in the United States showing just how people envisioned this threat. But it was, there wasn't much scientific data about these things. It was clear by then that this disease, for example, black stem rust, it would actually go between two different species of plants, common barberry and wheat. But how far could it go? How high could it go? Were there, pathways from country to country that they could travel? Nobody knew. And so in my book, I write about a long forgotten scientist who did amazing work. His name is Fred Meyer. He was a US Department of Agriculture plant pathologist, and he got really curious about this. And he set out in the 1930s to really chart the presence of these living things in the air, these things that were threatening American food. He was able to get into planes to do this rather than just climb up on a glacier. This is actually a picture of Meyer in a cockpit demonstrating how he catches these things. Those are wooden handles with petri dishes stuck to them. And so he would go up 5,000, 8,000, 10,000 feet in the air and just wave these around and bring them back to his lab. Now, people thought he was kind of crazy, the pilots, for example. But as these images show, if he let his petri dishes grow in inoculation chambers, he was actually able to grow colonies of fungi and other organisms, demonstrating that, yes, indeed, there were living things up in the clouds. Meyer was a real networker, and so he was actually able to get the Lindberghs to get involved with this. And so when they were taking a trip over Greenland and preparing for this trip, he gave them a device to catch anything that might be there over the Arctic. And lo and behold, the Lindberghs, they tried catching stuff high above Greenland and the Arctic, and they found it. And this was a real sensation when they came back and Meyer reported these results. He was also able to get Amelia Earhart to help out. So when Amelia Earhart went on her ill-fated journey around the world, she was actually collecting spores and other life for Fred Meyer. The most extreme collaboration he got involved with was actually these three gentlemen who decided they wanted to go to the stratosphere. And the way to do that is they got inside that metal ball behind them and they blew up an incredible balloon, and that took them miles and miles into the sky. And they took with them devices that Meyer had created to carry fungal spores and other forms of life into the stratosphere to see if they could survive there, and other devices to see if you could actually catch things up there. And this is a picture where they're back in Fred Meyer's lab. He's there holding the tubes. This was in National Geographic. New York Times covered this. And yes, indeed, life could survive 13 miles in the sky, and you could actually catch things that were floating around there as well. So this was really mind-blowing at the time. If you look at newspaper articles and so on, it really got people thinking, how high can life go? Can it go into outer space? Now, for human health, the story is different and messier. See, because the thing is that as people like Robert Koch were really advancing the germ theory of disease into its modern form, they were actually being able to sort of identify specific germs that cause specific diseases. And so for cholera, for example, Koch and others were able to demonstrate it's not caused by miasma, it's caused by one kind of bacteria, what we call Vibrio cholerae, and that doesn't spread through the air. It spreads through water, contaminated water. And so when there was an outbreak in Hamburg in 1894, early 1890s, Koch did not address it by trying to get rid of miasmas that didn't exist. He brought in clean drinking water. He disinfected houses where people had been sick and so on. And he took these measures to prevent the spread of cholera. And he did. The epidemic ended, and Germany did not have a major cholera epidemic after that. So it wasn't the air that really mattered. And miasmas were ruled out, and so was transmission through the air. Other diseases would be spread through contaminated food. Other diseases would be spread by mosquitoes. But the air itself was not really considered a vehicle of transmission. So Charles Chapin, who is one of the 20th century's great American public health leaders, he declared in the early 1900s, it will be a great relief to most persons to be freed from the specter of infected air, a specter which has pursued the race from the time of Hippocrates. He's talking about miasmas, and he's saying, relax. You don't have to be scared about the air around you harboring diseases. Instead, you wash your hands, you make sure your food is cleaned, raw milk, pasteurize it, and you will be protected from diseases through that means. This was a huge revolution in public health. I mean, and I don't want to diminish what they did. Children suddenly were much more likely to survive into adulthood because of so many diseases being stopped by understanding how they're transmitted. But in the book, I write about how in the 1930s, William Firth Wells and his wife, Mildred Week Wells, two outsiders, really. He was a sanitarian. His expertise was in water pollution, and she was a physician. They got the idea that actually maybe disease can spread through the air. They developed a theory that, as I'm talking, as you're breathing, we're releasing tiny microscopic droplets that may harbor bacteria or viruses. And those droplets, if they're small enough, they can float. They can float around for hours. And if they float around for hours, there's a chance that somebody nearby can breathe them in. So they refer to this as airborne infection. Airborne really meaning that things can spread for long distances or be present in the air for a long period of time. It's not some sort of temporary thing where, I cough and big droplets fly out and just crash to the ground or hit someone in the face. It's very different. Wells has invented all sorts of new technology to demonstrate this. This was a device called the air centrifuge, which they used to capture germs from the air. And this is a giant tank that Wells used in the basement of a building at the Harvard School of Public Health to prove how these droplets could float around. And what he also found was that you could use ultraviolet light to disinfect air. This is actually an ultraviolet light he's using for his experiments. So if air was passing through an ultraviolet lamp, he was able to demonstrate that the bacteria, the viruses would be wiped out. Published a paper on this in 1936, and this really got the Welleses really excited about being able to deliver clean air. Mildred Wells once wrote to someone in a letter, "I believe that a provision of pure air for children and adults to breathe should be looked upon as of equal importance to the provision of pure water and pure milk." So they were on a mission, and they actually did some really important work where they really demonstrated that things could work. They installed ultraviolet lamps in schools in Philadelphia. These lamps would shine ultraviolet light upwards, so they weren't shining down and harming the children. But as the air circulated over the lamps, they would disinfect it. And so when there was a big measles outbreak in 1940 in Philadelphia, the kids in these classrooms had a 10 times lower rate of measles than the kids in other classrooms, even in the same school. This was no secret. The Welleses have been long forgotten, but at the time in the 1930s, they were famous. They were the stuff of newspaper articles. They gave highly attended lectures. And so people were very hopeful that they were going to be indeed providing pure air with the help of things like UV light. And then you wouldn't have to worry about major airborne pandemics. The 1918 flu pandemic was still hanging over people, haunting them. Maybe the Welleses would make that a thing of the past. Meyer heard about the Welleses, and he networked with them and with other people, and he actually convinced the US government to open up a whole research program with a lab attached to it to study life in the air. And in 1937, at the end of the first meeting of his committee, he announced that they'd launched a new branch of science, aerobiology. And this was the first time that word was used. So you can really pin down when this science, aerobiology, started. It not only did it start November 12th, 1937, it started at about 4:15 p.m. Eastern time. Unfortunately, soon after it started, it took a nosedive, unfortunately, in a very literal sense. Fred Meyer was looking forward to being in charge of this new program, and his first project was to go on a plane, the Hawaii Clipper, which was going to go across the Pacific, and he was going to catch organisms in the air. And this is him showing off one of the instruments he's going to use to a colleague. He never came back. That plane disappeared over the Pacific. It was a huge sensation at the time because it was a glamorous plane that few people could afford to travel on. And then lo and behold, it turns out that these scientists doing this mysterious scientific research had disappeared with it. So aerobiology as a science did not take off the way it might have. Meteorology, the weather science, was starting at the same time, and that really blossomed. Aerobiology kind of stalled out. No one really took Meyer's place, unfortunately. And as I write in the book, the whole science really did suffer as a result of that. I just want to fast forward now to 2020 to kind of look at sort of the legacy of what had happened in the 1930s. In 2020, there was this mysterious new illness that appeared in China. Nobody quite knew what it was. And it took a while to figure out that this was a coronavirus, but it wasn't clear how it was spreading. Because people did not, I should say that the Welleses, they had really pushed to get people to accept airborne infection in the 1930s. And the public health community, eventually really just came to push back against it. They really stuck with that view that Charles Chapin had, that the air is not something to worry about. The main thing to worry about in terms of transmission would be touching surfaces, washing your hands, clean food, clean water, and so on. And so for a respiratory disease, they really believed that the big droplets that came out of your mouth or your nose, they would land on surfaces or be on your hand, and you'd transfer them to, say, groceries, which is why we were all wiping off our groceries at the beginning of the pandemic. And as I write in the book, it took a lot of fighting for a small group of scientists who recognized what the Welleses were saying to really carry that over to say, like, no, this is airborne. And, that small group of scientists who was saying we need to take seriously the possibility that this is airborne, that, wiping off your groceries or putting up some plexiglass is not going to stop this. They got a lot of pushback from places like the World Health Organization. So, for example, in March 2020, they stated, could not make clear, fact, COVID-19 is not airborne. So this is what they were saying, the world's leading public health agency. And they were basing that on sort of historical assumptions that went back really over a century. Now, in fairness, the World Health Organization changed its tune. So, today they recognize it's airborne. They support a lot of research on airborne spread, but it took a long time for them to turn. Really, the first time that they were clear in print that COVID is airborne was almost 2 years after that initial statement that COVID is not airborne. This is the first time in December 2021 that they recognized that long-range airborne transmission is a real danger when it comes to COVID. So as I talk about in my book, that has been a real revelation, and it really helped to set focus back on aerobiology again. And scientists are now trying to think about this living world around us that we breathe. This what they call the aerobiome. The aerobiome is all that life in the air. And it's not just viruses. It includes things like insects. Insects actually in much bigger numbers than people previously appreciated. This is actually a radar image that led meteorologists to think that there was a big storm in California a few years ago. And they actually called someone who was underneath there and said, like, hey, what's the storm like? And that person said, there's no storm. There are a lot of ladybugs flying around, though. And it turned out that there was a vast swarm of ladybugs miles in the air flying overhead. And scientists are recognizing that indeed there can be trillions of insects, literally trillions of insects that will fly along these highways through the sky that they just didn't know about before. As for invisible life, it's not just the COVID viruses we may cough up. The ocean itself is spewing life into the air. The ocean is full of microbes, especially on the surface. And it turns out that waves, when they break, they generate lots of tiny droplets, kind of like the way we breathe. And those droplets, if they get kicked up by the wind, they can go up miles into the sky. And so the oceans are a major source of life in the air. Land is as well. And it turns out that fire is a major source of life in the air. It pumps up vast numbers of bacteria and fungi and other organisms way, way up into the air. And so, in fact, when you look up at a cloud, you should think of this as something that's alive. It really is. By which I mean that there can be billions, perhaps trillions of organisms in a cloud, mostly bacteria, but also things like lichen and fungi and so on. And some of them can actually feed on the organic compounds in these water droplets and grow very slowly, but they're growing. And they can ride along in these clouds, and eventually they will make their way back down to the ground. But they can travel for hundreds or even thousands of miles, going through clouds or through clear sky. So again, this should change the way that you look at the world around you and above you, and maybe even other worlds. There are actually astrobiologists who are thinking that if our clouds have life, then maybe clouds on other planets could harbor life. Venus, for example, has a surface that's way too hot for any life to survive. But some scientists have suggested that maybe life began on Venus when it was cooler. Some of it got up into the sky and eventually adapted to the cooler conditions in the clouds and are staying in the clouds while the surface is just too hot for them. This is just an idea right now. There's no evidence of it yet. There's no Lindbergh who has flown through those clouds and caught life. But we could try. We could certainly try. We could fly probes through the clouds of Venus with, sensors for detecting life and see what we might find. And I, for one, would be very curious to see what might be there as well. So thank you so much. I'm going to come out of my slide talk, and then I will be more than happy to answer whatever questions you might have. Thank you again.
Well, Carl, I hope you can hear me, because I know that there's been some problems, and I apologize for that. I can fine. As we wait for some questions, I did have a start with, and that is you come back often, let's see, to Mildred and William Wales in the book and the role they play. Did you know about them before you started the project, or did you discover their work while you were researching for them?
Great question. When I was reporting on the pandemic for the New York Times, I was kind of confused by the debate that was happening, that there was this debate about whether COVID was airborne or not. And I thought, I don't understand why this is a source of debate. This seems like it should be simple. And so I talked to a scientist I know who's an expert on these things, Donald Milton at the University of Maryland. He figures in the book. I said, can you, is there a history here? Am I missing something? And he said, do you know about William and Mildred Wales? And I said, honestly, I do not. And he's like, well, that's where you need to start. Now, at the time, there was very little written about them. Megan Maltini actually wrote a great piece in Wired in 2020 about the Waleses and what was and the controversy that was happening in 2020. But there wasn't like a biography of them, and in fact, when you looked, William Wales published one book, and then there were a few articles, and I don't know, it just didn't add up, and I wasn't really sure what to do. But then I noticed, a graduate student had written a PhD thesis that includes some stuff on the Waleses, and he made a reference to some papers that he had read at an archive. The Rockefeller Center has an archive, and so I went over there. It's about an hour and a half from where I live, just on the off chance there might be something there. And it turned out there were maybe 50 or 60 boxes of documents, letters, unpublished memos, and that really got me going. And that actually offered a really fascinating, really tragic picture of this couple who were so committed to trying to get people to recognize the threat of airborne disease. And when they died, Mildred died in 1957, I believe, and Wales in 1963. They were forgotten and their ideas were dismissed, and we all paid the price for that. So discovering the Waleses getting to know them in this book was a real highlight of the experience.
Yeah, excellent answer. Thank you. Let's see. Do we have another question coming up? Let's see. Okay. All right. After you scare the daylights out of us a little bit, at one point you relate that some scientists were very concerned that AIDS might become airborne. Can you assuage our fears on this, Carl, please?
Sure. Yeah. AIDS is not going to become airborne. There you go. However, it is true that Nobel Prize-winning scientists like Joshua Lederberg in the 1990s, in the 1980s, when HIV, AIDS was first emerged and HIV was discovered, the virus that causes it, he really liked to scare people by saying maybe AIDS can evolve, maybe HIV can evolve to spread through the air instead of being spread through blood and sexual transmission. Lederberg had an agenda there. I mean, Lederberg was trying to get people to respect pathogens, viruses and bacteria, and their capacity to evolve and the dangers that they posed. And what was important to Lederberg was like AIDS was a disease that did not exist before, like the people didn't know about before it emerged. And he said there are going to be more diseases that will emerge, and he was right on that score. But he really he played on people's fears. I mean, airborne infection is also, as I write about in the book, the stuff of science fiction nightmares. Whether it's the Andromeda strain or outbreak, it's the kind of thing that can really scare you, because now, like, instead of just being careful to wash your hands or be careful what you eat, like, you just breathe it in. We have to breathe. And so the idea of airborne infection can be much more scary. So indeed, that is a part of the book.
All right. Thank you. All right, now here's a question from a wonderful person that I both know, Eugenie Scott of the Bay Area Skeptics. COVID was spread by droplets, although it took quite a while to realize that. But surely COVID isn't the first disease to spread this. Were other droplet spread diseases known before COVID?
Yes. And so, in the book, I go, into much more detail on the history of determining airborne disease, and what kind of diseases can spread through the air. So, for example, so the Welleses were quite convinced in the 1930s that measles is airborne. This was not the consensus, and even though they could protect children with these UV lights from measles outbreaks, the public health community still was very reluctant to accept that it's airborne. It wasn't really until the 1970s that a couple of Welles's disciples did additional research to really kind of finally get people to accept that measles were airborne. William Wells, before he died, I write about this amazing experiment that he engineered at a VA hospital in Baltimore for tuberculosis. And there he was really able to demonstrate conclusively that, yes, indeed, tuberculosis, the bacteria that causes tuberculosis, when patients exhale it can get into the air and it can cause infections. He had a guinea pig colony at the hospital, and he would pump the air into their room, and they would get tuberculosis. And so there were things like measles and tuberculosis and others, but when COVID came along, there was just this default that this is just not how diseases spread. And there might be one or two exceptions, but your default assumption should be that it doesn't spread that way. And that was a big mistake, as we saw with COVID.
Indeed. Any more? Here's one from our friend David. And I was hoping I'd get this question. Was ultraviolet used during the COVID pandemic? And can you just speak to the use of the ultraviolet? And because you talk about that quite a bit in the book too, and
Yeah.
And where that went.
So the idea of using ultraviolet light to essentially disinfect the air of diseases, the Welleses were championing this for a long time, and a few people would pick it up. In the 1930s, there was a big flurry of interest. Hospitals were installing them in pediatrics wards and so on, but it kind of tapered off. So by the time of the COVID pandemic came, they were installed in hospitals where there were cases of tuberculosis they were dealing with, for example, because tuberculosis was one of these diseases where everyone was recognizing that it was indeed airborne. But some of the experts who said, hey, we think COVID is airborne, also said, we can fight it in the air. There are things you can do. I mean, simple things like opening a window to get ventilation, or just, bringing in air purifiers, changing the way your HVAC systems works, or in some cases, use ultraviolet lamps. And the whole technology of ultraviolet lamps has really improved dramatically. And so I write about how actually one tuberculosis expert at Harvard Medical School, he had retired and he liked to sing. He liked to sing cabaret at a local club. And how do you do that in a pandemic? Well, he installed ultraviolet lamps in this cabaret, and I actually went there and watched him sing and some other people sing, and as far as he can tell, there's been no COVID transmission that's taken place from people, mingling in the room. And he can sort of measure that there are that the UV light is sufficient to eliminate most of the viruses in the room. So that doesn't, that's not to say that ultraviolet lights are like the solution, but certainly in order to just improve our basic public health and to prepare for the next pandemic, there will be one, we should be thinking about things like ultraviolet light.
Any answer coming up on that? Didn't hear that. That's all right. Next question. If UV has such efficacy for killing microbes and it's safe with the upturned light, isn't this process used universally today?
So actually, I should point out that that upturned light I was referring to, like that was with old-fashioned lamps. Like the Welleses were doing that in the 1940s. There are UV lamps now that are designed for disinfecting air, and they use a particular window of UV frequencies where they can actually be pointed down safely. They can't penetrate the eye, they can't penetrate the skin, but they can knock out viruses and bacteria in the air, and that's been demonstrated in experiments at places like Columbia University. So they work. So why doesn't everybody use them? Well, for starters, for now, they are not cheap. This is not just a light bulb. They can cost over $1,000. And so the people who have been inventing these and have been promoting these, they are hopeful that, like so much technology, that the price will come down, and that if people do start to recognize the importance, the value of it, scale of production will cause the price to drop further. That's possible. But yeah, so that's one reason. I mean, people have like a general, I think people have a general suspicion of ultraviolet light. They think it's dangerous. And, I mean, and I would say that, there is more research that can be done on UV light. I mean, there is a debate, for example, about what happens to the air when you keep UV lights just running all the time, because those rays are not just disinfecting, the air of viruses and bacteria, but the UV light can actually, hit molecules in the air and actually cause chemical reactions that might produce some molecules that essentially create air pollution, indoor air pollution, and that would not be good. And so people are working on, measuring those levels. Is that really something to be concerned about? And then are there strategies to address that?
What an interesting question to ask, and a nice answer. Thank you very much. Here's a quickie from somebody who calls himself Paradox, I guess. I'm having trouble pronouncing that. How do bacteria find food in the clouds? What do they eat?
Yeah, so I mean, obviously, like clouds do not have hamburgers and milkshakes floating around in them. But when the water that forms clouds evaporates from the land or from the ocean, it's not pure distilled water. It's got lots of stuff in it, and that stuff can include lots of organic compounds. And so if bacteria end up in a droplet where there's some stuff to eat, again, we're just talking about molecules that they can absorb and they can generate fuel from. It does look like that they have some active metabolism in clouds. There's enough food in there for at least some species to grow very slowly, but bacteria are actually really good at growing very slowly. They most of the time they don't have a lot of food to eat, so when they find it, they make the most of it. And one place they make the most of it is in clouds.
Well, it reminds me. I think in Carl Sagan's Cosmos, I think there's a chapter where he talks about how there possibly could be life on Jupiter, essentially up in the atmosphere, not on the surface, because there really isn't a surface, of course, for Jupiter. Cool. Any other questions? I think there's one coming up here. Can you speak to the seeming paradox that, and obviously not, we're not talking about measles here, but frequently diseases that are very deadly are not as virulent, whereas the very infectious ones are milder on the victims?
Yeah, this is certainly a question that infectious disease experts have wondered about a lot. Because you can have diseases that are more or less virulent. There are some viruses, like Ebola. People who do not have access to good medical care, Ebola can be 50% or 80% deadly. Whereas a cold virus is usually not gonna kill you. It's not even gonna put you in the hospital. So there is this huge range of levels of virulence, and it's also true that pathogens, some of them spread a lot more easily than others. So COVID spreads very well. Measles spreads really, really well. And it spreads through the air really well. And that's one of the reasons why, because childhood vaccine levels have been going down, we in the United States have been seeing these little explosions of new measles cases. And I would expect that as it becomes more of a hassle for parents to get their kids measles shots, and as school requirements go away in places like Florida, we're going to see a lot more measles in the United States, a lot more. So what's the relationship? Some people have said, like, well, pathogens start out very deadly, but don't spread very well, and then they evolve to become milder and spread more easily. That happens in some cases, but it's not a rule. It's not a law. And so you can't expect necessarily that diseases will necessarily get nicer. That's not the case. In fact, sometimes they can go the other way.
But it's not a just so story either. It is a thing, right? Yeah, or seems to be.
Yeah, well, it's part of a bigger, more complex story. That's for sure. There are a lot of different dimensions to how diseases evolve and how they spread. And so you really need to, you need to look at each disease and really understand it in its full natural history. And then you have to recognize that it's going to change. So the COVID that we we're still dealing with COVID. Thousands of people a year in the United States die of COVID every year. But, we are getting infected by descendants of the original COVID. They're molecularly, they're different. They have different strategies for getting into us. They're almost a different disease, really.
When you say thousands of people are dying of COVID, we really need to hear that. I'm not hearing that enough, but we really need to hear that message. Okay, Peter asks, can you talk about valley fever?
Sure, yeah, and this is something I talk about in the book, and just to preface this, the Welleses were really focused on the threat of airborne disease in our modern interior world. We spend in a place like the United States, you spend 80-90% of your life indoors. And the indoor environment is really, it's a place that can really build up a supply of airborne pathogens because there's so little circulation. So I'm exhaling and, my droplets just keep, filling up the room. And so if I've got COVID or measles or what have you, that increases the risk of the people who share the space with me. But that doesn't mean that human diseases can't spread long distances through the air. And valley fever is an important example of that. Valley fever is caused by a fungus. Now, normally the fungus is totally happy and lives underground in places like Arizona, arid regions of the Americas. And it just sort of feeds the way fungi do underground. And it forms spores. And a storm can kick up the dust from the ground, and that might include spores, which can then travel on these highways through the air along with the rest of the aerobiome. And if you could be hundreds of miles away, and if you had the misfortune to breathe a lot of these spores in, or maybe you have a weak immune system and you even just breathe in a few, the fungi can get into your airway and sprout their little tendrils, kind of like an elastic, and then just grow. And slowly over the course of, it can take years for them to kill you. And so valley fever is becoming more common in the American West. And part of that is climate change. In other words, there are more arid regions, and they're spreading because as it's getting drier, and so that's more range for this fungus to grow. And when it gets into the air, it can reach further into human populations. And also, development, digging up the ground also, leads to more production of this stuff, and more population downwind of valley fever just means we're going to have more cases. And there's not really good treatment for it, unfortunately. Fungi can be really hard to treat medically. I've talked to doctors in Arizona who treat them regularly, and it's tough. It's tough. And and so this is there may even be diseases like valley fever I write about in the book that actually can travel across an ocean, and then we inhale them. So this is a whole frontier of aerobiology that scientists are still figuring out.
All kinds of good news. All right. Do you have time for one more?
Sure.
All right, because we're coming up on the end here. I know it's late for you, and I want to thank you again for being so generous with your time. Are you aware? This is David again from the Bay Area Skeptics. Are you aware of the young adult novel Air-Borne by Kenneth Opel, where there are multicellular, super lightweight animals high in the atmosphere? It's meant to be fiction, of course.
That's very interesting to hear about. I always enjoy, science fiction that parallels what scientists are actually discovering about the world, and I actually write about science fiction in Air-Borne. I didn't mention this novel by Kenneth Opel, but it sounds interesting, and it sounds like what you were referring to earlier, where Carl Sagan at one point did envision, maybe you could have sort of balloon-like, animal-like creatures in the clouds of Jupiter. Sounds like he's getting inspiration from that. I will say that's, Carl Sagan had lots of great ideas that have been very influential. Nobody thinks that there are any animals living in the clouds of Jupiter. However, this idea that there might be microbes in the clouds of Venus, that's a live issue. That is a subject of active debate. A lot of people don't buy it, and that's fine. That's what scientific debates are for. But in that respect, that basic idea of life in the clouds of alien worlds, that's something that scientists are taking seriously.
Well, Carl, I want to thank you so much. This has been a wonderful talk, and it's a wonderful book. I want to hold it up again. This is Carl's book, Air-Borne. Okay, you can find it on Amazon or anywhere else. All right, it came out, and it's a great read. And so, thank you so much, Carl, and I hope we have you again.
Thanks for having me. It was a real pleasure. Thanks so much, and they're great questions.
All right, and then I want to say to our watchers, again, the next Skep Talk will be Thursday, November 13th. We'll nail down the time soon. We're working on that. Our guest will be Nathan Lentz. He'll be discussing his new book, The Sexual Evolution. I imagine we'll get a lot of people for that. So, for the Bay Area Skeptics, this is Bill Patterson. Thanking you so much for tuning in, and we'll see you next time. Good night.